In this video, we're going to talk about adding electric fields. And you have to remember that electric fields are vectors. You have to draw arrows. And if you remember, for vectors, you have to add them to. Now, often there's going to be symmetry or some right angles in there, which is going to make it pretty easy. But you have to remember they're vectors, and technically to add vectors, we have to use the tip-to-tail method. Now, I have an example here. I have a 2 microcoulomb charge and a -4 microcoulomb charge. And what is the net electric field at the origin? So I'm finding the electric field right here at the origin. Remember, you don't find electric field at the points, at the charges. You find the electric field at some point away from the charges. Now, first I'm going to look at the directions. So I have a +2 charge here at the origin. Remember, electric fields point away from positives, so the electric field due to that one is going to point down. We're going to label that one E, maybe for the +2. And then for this one, I imagine myself the origin, and electric fields point towards negative, so it's going to point this way, towards this negative charge. So that's going to be my E -4. Now I have to find the size of them. All right, so E2, we're going to use this equation, K³ over R squared. K is 9 times 10 to the 9th. Q for this one is 2. And the micro, the little mu symbol here, stands for times 10 to the -6th divided by R. R is the distance between them. This is at the origin. This is at 4. So over 4 squared. And that's going to give us a value of 1125 newtons per coulomb. And we're going to remember that that one is downward. Now, E for the -4 charge. Same equation, K³ over R squared. 9 times 10 to the 9th. 4 times 10 to the -6th. Divided by the distance for this one is 2, because I'm at the origin, and this is the -2. So 2 squared. And that's going to give me 9,000 newtons per coulomb. And we're going to remember that that one is to the left, like we drew on the diagram. Now to find the net, I'm going to redraw this. So I have this guy here. I have 1125 down. And I have 9,000 to the left. And in order to describe it, I have to find the magnitude and the direction of the net. So I have to make them tip to tail. So I'm going to take the 1125, say, over here. And then my net is going to be going this way. I got to find that. I got to find the angle. Well, since these are at right angles, I can use the Pythagorean theorem. So E net squared equals 9,000 squared plus 1125 squared. So I would square them, add it together, and take the square roots, and I'll end up with a net of 9,070 per coulomb. Now for the direction, I'm looking for this angle, and I have this side is the opposite is 1125, and the adjacent is 9,000. Opposite and adjacent is tangent. So tangent of theta is equal to 1125 divided by 9,000. So I would divide that out and then do inverse tan. I get the angle by itself, and I get theta equals 7.1 degrees. And I would say it's going down this way. So we would say below, and then this way is negative x. So below the negative x axis. That's the way to say that. Okay, at the top of the next page, we have our next example. Okay, so I have a +2 microcoulomb charge, a -2 microcoulomb charge, place is shown, and I want to find the net electric field at the origin first. We'll do that over here. Okay. So at the origin, I have to think about what's happening. I have a +2 over here. I imagine myself at the origin. Electric field's pointing which way for positives? Away from positives. So I'm going to write E with a plus 2 for that one. Now, for the negative 2, I imagine myself the origin, electric field point towards negative charges. So it's going to be this way. So this is going to be E for the negative 2. So it turns out they're both going in the same direction. So E2 is K cubed over R squared. 9 times 10 to the 9th times 2 times 10 to the minus 6th over our distance between those is 3. So over 3 squared. And that's going to give me a value of 2,000 per coulomb left. Now, E for minus 2, everything's identical, right? It's the same size charge. It's charge 2, so the negative sign. It's the same distance away, so that's also going to be 2,000 newtons per coulomb. I don't have to redo the math. And that's going to be left. Now, if they're in the same direction, what do I do to find the net? I can just add them. So E net is going to equal 2,000 plus 2,000 equals 4,000 newtons per coulomb. Now, if they're in opposite directions, what would I do? I would just subtract. Now, the next one's going to be a bit harder. It's finding it at point P. So first, let's kind of make a little, let's draw which way our electric fields are going to point. So if I'm at point P, which way am I going to point because of this positive charge over here? I point away from it, so I'm going to draw a little dotted line in here, and then I'm going to go away from it up that way. So that's going to be the E for the plus 2. Then I imagine myself here at point P. Which way am I going to go because of the negative charge? Toward negative charge. So I'm going to draw this one towards it like this. Now, I'll label that one E minus 2. Now, this is going to be a little trickier because I have to find the size, and for the direction, I'm going to have to find an angle. And the angles I'm going to want are that angle and then this angle. It turns out they're the same due to symmetry. Okay? And they are the same. This angle here is the same as this angle here. So I'm going to use this graph to figure out what that angle is. And I also need to know the distance. I'll get to that in a second. So first, we're going to say E for the plus 2 is K cubed over R squared is 9 times 10 to the 9th times Q, 2 times 10 to the minus 6 over, what's R? R is the distance from my point to my charge, so it's this distance here. So this is going to be R, so I'm going to figure out how to find that. And I'm going to use the Pythagorean theorem. R squared is equal to, this side over here is 3, and then this side up here is 4. And if I do the math out, I'm going to get R equals 5. Now, if you recognize that this is a 3, 4, 5 triangle, you wouldn't necessarily have to do the math. So we just found that the R over here is 5. Now, at the same time, I'm going to find this angle, because I know I'm going to need it, because I need this angle up here to do the same thing. So if I look at this triangle, I have the opposite side and the adjacent side. Opposite adjacent is tangent, so tan theta is equal to the opposite is this height here, which is 4, and the adjacent is this side here, which is 3, and that's going to give me that theta equals 53.1 degrees. So now I can finish this off. We're going to have over 5 squared, and that's going to equal 720 newtons per coulomb, and we're going to say at 53.1 degrees above plus x, because it's this one I'm finding here. Now, E for the minus 2, everything is the same, okay? We still have a charge of 2, it's the same distance away, so I know the amount of this one is going to be 720 newtons per coulomb. And the angle is still going to be 53, but it's below x, so 53.1 degrees below x. Now to find the net, I'm going to resketch this just like this. So I have E for the plus 2 is 720 and then this angle is 53.1. I have E minus 2 is 720, and this angle is 53.1. And if I think about it, everything is symmetrical. Which way is this thing going to go? And it turns out my net is going to be straight to the left. The up and down parts are going to cancel. So I'm going to kind of draw in here. We're going to call that EX, this EY, and then for the other one I have EX is the same, and EY going down this way. The EYs are in opposite direction. They're going to cancel. I'm going to make a note of that. EYs cancel. And I have both EXs are going to the left, so they're going to add. So how do I find that EX? It's the adjacent side of this triangle. I have the hypotenuse, adjacent hypotenuse cosine. So cosine of 53.1 equals EX over 720. If I solve that, I'll get EX equals 432. And I have two of those, so to find my E net, equal 2 times what EX was, so 2 times 432 is going to be 864 per Coulomb, and my direction, remember, is going to be left. So, those are a little bit tricky, but kind of follow the process step by step, and hopefully they will make sense.